Next problem is design DFA where every A is followed by B over input A comma B. So here in the question, the input is given to us. Summation is equal to A comma B. Certain problems are there for which it's you may not be able to construct the transition table initially. So there is another approach where you can start with the transition diagram and then construct the transition table. Sometimes it gives you the right answer in that way. So here it is mentioned that every A is followed by a B. If A is there, then it should be followed by a B and then only you will accept it. If A is there and another A comes in, then you should reject it. So accordingly, we have to choose the states. So we can start with Q0 initially. Now, suppose A comes in. So we'll move to another state, Q1. A comes in, we move to another state, Q1. Now B comes in. Then we should go to the final state. Now, suppose initially B comes in. There is no A present. Then also you should be able to accept. So what we do is we make the start state final, and any number of B's, if they come in and there is no A present, then also it should be accepted. So suppose there are 5 B's in the string, there is no A, then also you should be able to accept it. So it will accept this. Suppose A is present, then B comes in, then you go to final state. So we can move to Q0 again. So A is followed by B. Then 4, 5 B's are there, another A comes in, then we move to the final state, that is Q0. Suppose A is there, we move to Q1. After A, we get another A. So we can move to another state called as Q2, which is like a dead state. So after A, another A comes in, we move to the dead state. And in Q2, if we get any A, what we will do? We'll stay in the same state. If any B is there, then also we'll stay in the same state Q2. So what is happening is our condition was A should be followed by B, then only it will go into the final state. But A, if it is followed by A, then it goes into a dead state. So from this, you can make the table. So we'll have we will have Q versus the states versus the input. So we'll have Q0 as the start state as well as the final state. Then we have Q1 and Q2. Q2 is like the dead state. When we get A as the input, we go to Q1. In Q0, if we get B as the input, we stay in the same state Q0. Q1, if we get A as the input, we move to Q2. Q1, if we get B as the input, we move to Q0. Q2, if we get A as the input, we stay in the same state. Q2, if we get another A, we stay in the same state. So this is how certain problems you can solve it by direct DFA construction and then coming to the transition table. So here we had started with the transition diagram and then we came to the transition table. And you can take some example over which it will be more clear. So AB is there followed by BA. So here in this case, it should be rejected. So Q0, when we get A, we move to Q1. We are left with BBA. Q1, when we get B, we go to Q0 followed by B. Q0, when we get B, we are in Q0 followed by A. Suppose we get in Q0, when we get A, we are in Q1. Q1 is a non-final state. Now we are in Q1 means it is not a final state and we are not accepting the string because every A is not followed by B. So this approach can also be used for solving this problem.